So writing equations of exponential functions, you're going to be able to write an equation in the form y equals ab to the x, given a table or a graph, and you can determine whether a contextual situation would best be modeled by growth or decay and write that equation as well. So the exponential equation is f of x equals ab to the x, where a is the initial amount or the starting value. So this is when x equals 0. It is your y-intercept. So kind of like in y equals mx plus b, where b is your y-intercept, right? A is your y-intercept for this. In the middle of teaching a lesson. B is the growth or decay factor. Remember that it's always multiplication, first of all. So do not say anything about division. You're going to have to make that a fraction if it's division. If you do not have a calculator, you will need one. So get up and get one. And x is the period of growth or decay. It can be time, and that's the typical. It doesn't have to be. So those are what those variables represent. F of x is the total amount of whatever you are finding. So whenever you are ready, you can flip to the next page. Sorry. Well, you're going to get my nice white long cardigan. Okay, again, flip when you are ready so I know you are ready. Perfect. Nari, there was no homework, never mind. I don't know why I'm even asking that question. All right, so write the equation for each of the tables below. So first of all, we have to determine if the function is exponential. So is the following function exponential? So what you can do is there's multiple ways to look at this. You can just see it and it's multiplying by what?
3.
Nope. Close though. What? 1/3. So how could you find that if you cannot see it? So you work from the top down to find that. If you are somebody that struggles with seeing it, if you do the bottom divided by the top, the next one divided by that one, 9 divided by 27, 27 divided by 81, what do those all simplify to?
1/3.
They all simplify to 1/3. So if you are somebody that struggles with just seeing what the heck is going on, right? Some of you might not be able to visually see that this is multiplying by 1/3 each time, although some of you might. You can check at each point there, as long as it's counting by 1, and you can see that they're all 1/3, so that's why your decay factor in this case is 1/3. So this is exponential. Is it growth or decay? Connor Clover. Decay, why? Yeah, 1/3 is less than 1. It's between 0 and 1. So what is your factor, your B value, Jordan? The factor is what you multiply by each time.
1/3.
And Connor, what is your initial value, A?
Like on the X or Y?
When X is 0.
Oh, 81.
So if you then go to write your equation, we know the equation is y equals AB to the x. So, Jordan Coward, what would that be? The equation.
It'd be y equals 81 parentheses 1/3.
1/3 to the x power, yep. So look at that and see what questions you have, whether it be, how did you find the decay factor? Or how did you determine its decay? Or how did you determine the initial value? Why did you just substitute into that equation? Are there any questions there? Because it can't. What was that? I don't know where that came from. Anyways, so are we doing okay? So again, some of you might be able to visually see what's happening here. What do you guys think is happening here? Multiplying by 4. So this is why I suggest that you guys just do the whole division thing, because it will get you your answer. 32 divided by 8 is 4. 8 divided by 2 is 4. Just set on my desk there, RC. Thank you. 2 divided by 1/2. If you were to do that in your calculator, yes, you would get 4. 1/2 divided by 1/8
Is 4.
would be 4. So you'll see that we get the same number over and over again, which is why that is exponential. You're multiplying by that same number over and over again. So is the following function exponential? Riley? Yeah, it's multiplying by the same number over and over again. Colin, is that growth or decay?
Alright, that is growth.
Why?
Because the numbers are going up.
Can't just say that. Remember, I marked, if you guys looked at your quizzes carefully enough, I marked a lot of you wrong for telling me that the numbers are going up, didn't I? Because it could be linear, right? Doesn't a linear go up too?
I got it. I got the answer.
Yeah.
It's multiplying by a factor of 4.
Which is bigger than?
1.
So that's what you guys need to be saying. You guys need to understand that it's A, multiplication, so that was good, and B, that it's bigger than 1. Because you need to be able to distinguish between linear and exponential. Okay, Alyssa, what is my B value, my multiplying factor? Good. And Mike, what is my initial value?
One-half.
Good. Please do not just tell me it's 1/8 just because it's the first one in the table. It is when x is 0. So that is why it is 1/2. So what is my final equation then, Brian?
Y equals 1/2 times 4.
To the?
X.
Yep, you need that x there to make it exponential. When the variable is the exponent, it is exponential. Oh, no. They just happen to be the 2 colors that are up there right now.
It's a Christmas miracle.
Shut up.
What's up? No, that's a complete. That would be like asking Josh. That would be like asking, can you switch the slope and the y-intercept and y equals mx plus b? Can you do that? No. Okay. So that's why. All right. They're different pieces. They mean different things. Do you need me to go back? No. Okay. So now we have to determine this one. So get your calculators out and start dividing from the top up. So you're going to do 0.064 divided by 0.32.
Oh, I put all that on the wrong slide. I put it on the bottom slide instead of the top slide.
Two not here.
No.
Okay, raise your hand when you got it, so I know that you're doing this. If you need help, let me know. Jana, what are you thinking? What does each one simplify to? Did anybody else get 0.2?
Hey, I got you.
Okay, did they all simplify to 0.2?
Oh, yes.
So, does that make this one exponential?
Yes. Sure. Well, if it's not exponential, you just continue to do everything after it. Like it doesn't
You can't do the other stuff after it if it's not
So you
exponential.
hope that they're all.
Not exponential.
Yeah.
But that's not going to be the case.
We should make it faster.
Fight me, Colin. Let's get you.
Do you know how much that, do you know how mentally that would do to you guys? Like what that would do to you guys?
That'd be awesome.
Ooh.
No, you guys would think you're doing everything wrong. Josh, is this exponential growth or decay? Why? Guys, please stop talking. We're having issues again. Which is what? You're right so far. You have half of it. What's the other half of it? Why isn't that?
It's less than
Good. It's not bigger than 1. So our factor is 0.2. Oh no.
You just divided.
Yeah, the inverse of multiplication is. So if you want to get to 0, you have to keep dividing by that number. Because the inverse, to undo something, you use the inverse. So divide 8 by 0.2, and what do you get?
40.
So divide, is that our initial value yet?
No.
So divide by 0.2 again, and you get?
200.
Holy.
Is that the initial amount?
Yes,
You
man.
get 80.
I don't know, because somebody said 80 to me, and I just wrote it down.
It's 200, yeah.
I think Connor said 80, and I just went with
No, I
it.
didn't. Don't blame stuff on me.
Yeah, it was all
He probably did.
You did say that, didn't you?
Global warming is my fault too. Isn't
No, it is not.
Yes, Connor.
All right. Okay,
What's this?
guys. So, Emma, what is the equation?
Y equals 200 multiplied 0.2.
What did you forget?
The exponent
Which is?
x.
Yep, guys, you guys keep forgetting that exponent. Don't forget that. I will mark it wrong.
Why did it smell like Lysol when?
I don't know.
Yeah, it does.
But you need to focus.
I am. I'm doing the next one without.
All right. So this one has an actual context to it. So it's the year and the population. So you'll do the division. So RC, do the first division. Tell me what 3,490 is divided by 2,167.
1.61.
I'm smelling it now. I don't know where that's coming from. Somebody just do something? Oh, thank you.
It'll be two of us against each other.
Okay, then we do 2,067 divided by 1,346. And Justin,
What?
do that division for me.
Do what division?
2,167 divided by 1,396. Or 1,346, sorry. Guys, you need to focus and you should be doing this. Face forward.
1.6099.
So we can round that to 1.61, right?
Sure.
All right, guys, I'm stopping every time you start talking until this class understands what I'm asking you. I don't mind you talking when you have time at the end of the hour. It's an issue when I'm trying to teach a lesson. Do you understand me?
Yes, ma'am.
Okay, so now we are going to do 1,346 divided by 836. Blaine, what number is that? You should be fine. Go sit down. You can do the other one later.
That.
Yep, that one looks good. We'll just do 2 decimal points. That's great. Then we would do 836 divided by 519, and what do we get? Brian, do 836 divided by 519.
1.61.
Does it round to 1.61? Or is it exactly 1.61?
It's 1.610.
Yeah, so it is. Okay.
Repeat it.
So we do 519, Kaylee, divided by 322.
You get 1.6.
Okay, and then we do Tanari, 322 divided by 200. So some of you guys noticed that I actually typed it in your calculators that it wasn't exactly 1.61. We divided it. But we rounded it. But this is talking about a contextual situation, so it's not going to be perfect. But it was pretty close to 1.61 for all of them. So yes, this is exponential. Jordan, is this growth or decay?
Growth.
Growth. The number is, what is 1.61? How do you know it's growth? You got to get this down. This is what a lot of you guys missed on your quiz. Why is this growth, Connor?
Because 1.61 is 61 is higher than 1.
Yeah, 1.61 is greater than 1. Remember, if your multiplier is greater than 1, it's growth. If it's between 0 and 1, it's decay. All right, we need to get that down. What is my factor? What am I multiplying by each time? Lexi, what's my factor? And if we do this as years since 1972, then this would make this one 0, 1, 2, 3, 4, 5, 6. Do you see how you can just start it at 1972 and say year since? We've done that before. So Grace, what is your starting value, your initial value? Good. Which means that my equation is what then? Riley, go ahead.
Y equals 200 multiplied by 1.61 to the exponent of x.
Yep. Okay, so questions so far on this stuff? Yeah.
Is it always x to the power
Yes.
of x?
Because that's your time span. Just like in y equals mx plus b, we always keep the y and the x in there. Same thing here. Okay? All right, so let's look at some graphs and do some word problems and do whatever else is on the back, and then we will get you guys your homework. Okay, so use the graphs to answer the questions. Write the equation of each model. So, find the growth factors for the two species. So what is the growth factor here? So if you make a table of values for both of them, sometimes that's the easiest thing to do, you can figure out the growth factor a little bit easier. I showed you guys how to figure it out if you cannot just see it. I know that for some of these, like this one, you might just be able to see it. So this one's at 1, 50, 2, 200, 3, 200. So these ones didn't give you the points because you could see them. They were exact points. Okay. So for the first graph, species X. What is the growth factor of species X?
3.
Who just said that?
Me.
Why is it 3?
Because 5 times 3 is 15.
Yep. 5 times 3 is 15. 15 times 3 is 45. 45 times 3 is 135, and so on and so forth. Okay, what about for species Y? What is the growth factor, Jordan Coward? How did you figure that out? So which one of those is growing faster? Tell me which one is growing faster, RC, species X or species Y?
Species X.
And why?
Because it's multiplying by a bigger number.
Yep, because 3 is bigger than 2. That's a bigger number. All right, what are the y-intercepts for the graphs? And explain what these y-intercepts mean in context. So, Colin, what is species X y-intercept?
What? Oh.
Oh, right, because, yeah, okay, so, so when x is at 0, the y is 5.
Okay, what does 0, 5 mean in terms of this problem?
Okay, so it means that, let's see, when species x at the time was 0, there were 5.
So it's the initial amount of species X is 5. Remember, whenever time is 0, it's the initial amount. So initial amount of species X so the initial amount of species X is 5. Sorry. Blaine, what is the y-intercept of species Y?
Wait, did he say me?
Yep. Blaine.
Oh, it's 25.
As an order pair.
0, 25.
And what does that mean in context?
That at the time of 0, the population was 25. At the time of 0.
The initial amount of species Y is 25. All right. Give me what? Huh? No. Cassie, give me the equation for species X. This is why you guys don't do well on things. You probably didn't even hear Cassie say a thing. First of all, she's quieter than all of you are. And second of all, you were talking. Pay attention. Don't get behind because you guys want to goof off. Do you understand me? Don't complain to me when you don't do well on things. Okay. Species Y. Jayla, what is the equation for species Y? Good. So it says, for what equation is the solution 5, 1,215? So all you have to do there is substitute in 5 for x in both of them and figure out which one has that solution. So go ahead and substitute that in and see which one has that solution.
Wait, what?
We wrote equations in the previous step.
Yeah.
It says which equation has the solution. So if you substitute 5 in for x, it will give you a y. If it matches that y, it's a solution. We've done this before. This is not the first time we've done this. Haven't we done this before? When we check for solutions, right? So x comma y. You're checking to see if this equals 1,215. If you substitute in 5. So what do you get when you do 5 times 3 to the 5th? What's 5 times 3? Sorry.
Wait, hold up. 1,215.
So that one is true, right? Did you guys try the other one?
Yeah.
And what did you get?
800.
Gosh.
So that's not equal, right? So the solution is for species X.
So that makes sense.
Okay. Let's determine if answer each word problem by first writing the correct exponential growth or decay function. So Fido did not have fleas when his owner took him to the kennel. When he returned from the kennel, he had 8 fleas. Each day, the number of fleas tripled.
Sue for that.
Spaghetti.
I don't think that's good.
No, this kennel is not good.
You could sue.
Yes. No good.
Poor Fido.
Maybe it's just.
What is the initial amount of fleas he had when he came home? Justin Powers.
Die.
What's the initial amount of fleas he had when he came home? 8. And how much are they growing by? Tripled, so that means 3. So your equation is y equals 8 times 3 to the x. Okay, so it says, assuming his owner cannot take him to the vet for the next 5 days, how many fleas will he have on the 5th day?
Wait, let me solve it, please. I want to prove my worth.
Hi, do you have any toys for the toy drive?
No, we do not.
Awesome.
That sounded
If you guys want to bring in toys for the toy drive, there's a chance to win like a pizza lunch or something. So
I was gonna say that.
I'll bring all my lists back.
they have to be new.
I want to see if there's no
Connor, why is your hand up?
I'm gonna ask if I did this right.
What did you get?
1,944.
Is that what everybody else got?
Oh.
Poor Fido.
A lot of fleas.
It's just his
That's a lot of
time.
damage.
He's not even a dog anymore.
He's
He's just a giant flea.
Whatever saves the dog.
Well, first of all, this kennel needs to be
This is why you get
closed down.
cats. This is
All
why you
right.
get fleas.
Last one. Your mom buys you a new car for your birthday. The original value of the car is $15,000. Each year it is worth 3/5 of its original value. Write a function that models the situation. So,
That's a cheap mom.
$15,000 is a lot of money.
Isn't it like really bad?
No, it isn't. That's actually a really nice car to be buying for a new
My brother's in
car.
car sales.
I like to lower the dollar.
Wait.
I would much rather, my child will be getting like a $3,000 car for their first car because they're most likely going to wreck it anyways.
Yay.
Moving on. So, what's up?
Oh, I was gonna say, my brother's 2011 Camaro was like $14,000.
Yeah, well. But Camaros don't. But Colin, a $14,000 Camaro probably is a V6 and probably doesn't have like a Hemi or anything in it, so it's probably not going to be like that great. My husband's obsessed with cars, and Camaros are his favorite cars.
I only like Camaros.
Yeah, Chevy's a better
What? So, Mike, the only reason I know a lot about cars is my husband. All right, we're almost done.
It only works for Chevy. Nobody needs a car. Chevys are better. Chevys are better.
She's trying to teach, stop talking.
Chevy's been at
All right. So, Josh, what is my initial value and my factor for this one?
Your initial value is 15,000.
Good. So it's y equals 15,000 times 3/5. That's a 3/5, not 315. That does not look like 3/5.
Oh.
Okay, that's better. To the x. Okay, so it says, assuming you will graduate from college in 6 years, how much will your car be valued at? Just so we know, a lot of people take a 5th year for college, just so you know. All right. So, in 6 years, substitute 6 in and get the answer out.
I want to solve this one and prove my worth. I'm a good student, I swear. Don't work on my laptop.
Grace, what was your answer?
No.
$699. Now, most cars probably wouldn't get to below $1,000. At some point, the factor would be less than this, but it does. Once you drive your car off the lot, it does start to depreciate, so you know.
So if you get like the best car, it's just